I've,
Thank you, Hari. So I hope everybody is able to see my screen.
Yes.
All right. So Hari has already walked us about what we have learned yesterday. And in today's session, we are going to take you on the journey from the raw data, whether it will be your streaming in real time or arriving in batches, and all the way to the intelligent outcome powered by an AI. By the end of today's session, you will understand how to build a modern lakehouse that doesn't just store data, but make it ready for AI agents. So let's take a bigger picture. A lakehouse isn't a product you buy, it's a pattern. Object stores with warehouse, reliability assembled from managed services. And over the next few slides, I will break it into the handful of decisions you actually have to make to build that system. The conversation that we have with our customers and what they are telling us is like they have data spread all across different places. They have data in databases, data warehouse, S3, third party sources, and all. And they want to do a combined analytics that touches and provide business insights from all these data sets, not just one or two siloed data sets. So they want to bring this together and enhance their product feature, their customer recommendations, their outreaches program. And they want to build their business by bringing together the insights from all these sources. So building a data lakes comes down to the three fundamental steps. So let's talk about the first step, which is the ingestion process. So how do we use?
sorry, Nidhi. I
Yeah.
think we have some Zoom controls blocking your screen. Is there a way that you can just?
Let me see if I can pull that. Is it better now?
I still see something called a tool has open or something like that. Yeah, if you can just close that one little thing. Yeah, there you go. Perfect.
Cool. Sorry about that. So let's talk about the ingestion. So like, how do we use data that is sitting at different location and different format? First, we need to choose a format that unifies all these data sources, right? And for that, we chose Apache Iceberg. Apache Iceberg is an open transactional format. It provides CDC, data snapshot, retention features, time travel, and schema evolution. Apart from these, Iceberg is also widely developed by the community as an open source, and it is widely adopted table format in the industry. So ingestion is not just about landing your data, it is landing it into the open Apache Iceberg. So there is one copy, right, for your read and write, and that's the interoperability we spend our session on. And now let's talk about the second step, which is the governance step, right? So now we know that the data is spread across different sources. You also have different permission model or governance for each of these data, right? What customer want is they want to unify all these data sources, and they also want to have a permission model that unifies and address all their data source historically in one place. And as your data set is growing or the number of users are growing, you also want a sophisticated permission model, right? That helps you scale. And like you don't have to perform a repetitive work, like you don't want to add the same permissions if the number of users are growing. You don't want to perform the same operations, right? That require a lot of maintenance effort. So you don't want to do all those things. So then something that unifies all these data sources and it's feature rich to provide permissions for their growing data need. Here comes the catalog federations. It can be the glue catalog, the S3 table, or the external catalog. that unifies under one governance lake formation view. So lake formation view, what does it provides? Basically, it provides the unified governance layer on top of the catalog for all your Iceberg tables. So you can use your lake formation to grant permissions and manage all the Iceberg tables. All the data sources that you are connected in your ingestion steps, right? For that, you can perform the permissions or the governance on that through lake formation. And how does lake formation do all that? That we will talk in our consumption steps. So consumption is where the value get created from your data sets. So we have enabled the data-driven decision making through analytics, machine learning, and now the AI agents. So let's take a step back on how the lake formation do all that. So for our consumptions, we have a client engines like your Athena SQL queries, your EMR, you have your third-party query engines, right? So these client engines makes a query on the table that you have in your catalog. And the query engine hits the Iceberg REST endpoints on your catalog, and the permissions are verified by the lake formation. It checks whether the calling entity, which is accessing the data, whether they have the correct permissions on your table or not. And once the permissions are verified and the entities have access, the lake formations provide the temporary access credential to the underlying data so that the consumer queries engine can access that data. So a few key principles that ties all these things together. So we have used the open Apache Iceberg format for interoperability. So you are not logged in, right? Like now you have access to multiple sources. We use the catalog federation, so your metadata is centralized and discoverable. And then we enable ubiquitous consumptions, meaning multiple engines and tools can access the same data without you have to duplicate that data based upon your growing business need. So in case if you have attended yesterday's session, you have recognized these concepts. Now we are going deeper into the ingestion sides. So let's talk about the ingestion, and then there are three main patterns that currently available to us. So we have like the zero ETL integration, which is like a low code, no code. They are the fastest way to get the data flowing from your supported sources without you are building any data pipeline. Less work, right? Then we have the streaming ingestion that handles your high-speed data at scale. So if you have your clickstream data or your IoT telemetry or the transaction events that are arriving continuously, then that's your stream ingestions can handle that. And then the third one which we have is the batch ingestion. That covers the large data set from a variety of sources, typically in your scheduled cadence. It can be your daily batch job or weekly or quarterly. So let's dive deeper into each of these and let's start with streaming and batch ingestion. So the two ingestion pattern you will lean on most. I will frame each one around the same question. What business questions does it let you answer? And how does Iceberg make it manageable at scale? So let's start with the world most of us grew up with is the batch process. So here's the reality. Most organization lives in today's world, right? You have your core business driver on one side, and then you have your analytics and AI use cases on the another side. Traditionally, the connection between these relies on like you were running regular batch job and then there was some manual intervention, right? This gets your data to your data warehouse, then the data lake, and then on top of that, you are building your business intelligence and maybe some basic personalization or recommendation on top of that. But there is a problem. The insights which we built on that data are delayed. By the time you see a trend, it may already be too late to act on, right? You are acting on the data that may be a minute or an hour old data, which is fine for a lot of core business driver, but a real constraint for others, especially for your AI applications. And genuinely with batch, we encounter the problem of scaling, multi-tenant, and high concurrencies. So now that when we add the real-time data pipeline into the picture, your streaming pipeline, we unlock entirely new capability, right? Like we no longer just looking at the yesterday's happening data, right? We have that data stream coming in, and then we can detect the anomalies as they occur. We can run our ML inferencing on the live data and surface the real-time insight to the business. These are those use cases which batch simply can't serve us, right? Like basically the ML inferencing or anomalies detection. Because by the time the batch job runs, the moment has already passed. And this all shifting is due to the agentic AI era, right? So the question is, how do we stream into an open Iceberg lakehouse? So why Apache Iceberg for streaming? So let's highlight a few reasons. It's provide high throughput, near real-time ingestion. So Iceberg is designed to handle massive write volume without compromising your read performance. You can query data instantly upon the arrival. You don't have to wait for the batch job to finish or your partition to close. Streaming read enables incremental data processing. And then your downstream consumer can pick up only what's new through the change data capture. B. Any questions?
This is mine.
Never mind. Go ahead. We'll have some time for Q&A at the end.
Got it. Sure. So like we were talking about the change data capture, right? So you can have that. Apart from that, Iceberg also give us scalability and performance. But the real magic is in the table feature for upsert and record level modification that lets you keep the latest states of your data. And that we will see in couple of subsequent slides. I have an example that you cannot achieve with your data lake format. Then schema evolution without you have to rewrite the data. Snapshot isolation for consistent read and time travel so that you can query the historical states. All these features are essential for your production streaming workloads. So let me walk you through the architecture. So we have our streaming source, that is the application using the AWS SDKs, your log files, and your agent pushing the data. So now you have your producer, which emits the event. That data flows into your stream storage, which buffers them for durability. So Amazon MSK for Kafka-based workload, or the Kinesis data stream for your native streaming service. And then we have the stream processing to transform and enrich. So like we have 4 options. You can use MSK Connect with the Iceberg, Kafka Sync connector. This is a fully managed and no coding is required. Then we have the data firehose, another managed option that handles the delivery, buffering, and your format conversion. Then we have Amazon managed service for Apache Flink. This is for when you need your custom transformation or complex event processing in flight. And then Amazon EMR that provides the maximum flexibility for Spark structured streaming or custom processing logic. Then we have the sync, which can be which goes to the Amazon S3 or the S3 table, and that lands the result into the Iceberg format, queryable immediately through your Amazon Athena. So this whole thing is built from managed services. So you are wiring one component with each other. This is so that you can achieve your data. The interesting design choice is the sync, and you have got several managed options here. So to simplify the decision, right, of which of these category you are going to choose. So if you want the low code or no code, then you can choose Amazon MSK Connect using the Iceberg Kafka Sync connector or Amazon Data Firehose. These are managed. You require very minimal configuration and great for straightforward ingestion patterns. But if you need a custom code for transformation, if you want to perform any enrichment or complex logic, then you can choose Amazon Managed Service for Apache Flink or EMR. There, you will get the full control over the processing logic beyond the data land in the Iceberg. Regardless of which path you choose, the data land in the same open Iceberg table and ready for any engine to query. Now that the data flowing in the real time, where does all the AI adds value? With the real-time data in open table, the AI, you can do the anomaly detection, ML inferencing, Gen AI, build your RAG, live personalizations and recommendations you can provide. And none of this work you can do on your stale data, which is siloed. It works because the Lakehouse give agent one open governed current copy, right? The fresh copy, so that you can use these. That's the thread connecting all these sections. So batch and streaming, both of these need a pipeline to build, right? Which require overhead, manual effort. Sometimes you will see a time slippage due to some issues. So for a big class of sources, there are ways in which almost no pipeline at all is required, and that we will see in our next slide in the zero ETL. So zero ETL is a managed lakehouse at its most. The pipeline you don't have to build. If your data already lives in your operational database, you don't have to do any coding. Just you can build through zero ETL. It will few clicks, you will have your data available. So it is simple to set up, easy to manage, and powerful analytics. Now let's switch from building your data strategy to simplify your data landscape. Zero ETL replication, replicate transactional data into your lakehouse in a near real time. It is a simple setup, a write to the Aurora, the RDS for MySQL, DynamoDB, and then it land into your open Iceberg or on managed S3 with a configurable CDC refresh interval. You don't have to write and extract transform load code to build, test, or like to babysit your pipeline. This is so good, right? That will save your efforts. You can optimize your cost. You can optimize your resource by removing that pipeline management entirely. And you will get a near real-time analytics and ML on petabytes of transactional data without touching your source system. And this is just done in 3 steps that we will see. So the these steps are very straightforward. Like you have to prepare your source data, select your data source, configure the connection, and this is where you will choose your which table or object to replicate. Then in the step 2, you will prepare your target, choose where you want to land your data, whether it will be S3 table, S3 or Redshift, and then configure the necessary permissions. And in the third step, the setup and launch the integration. The service handle the initial seed load, your initial load, and then continuously replicate changes via CDC. And we will see that as well in the subsequent slide. That's it. You don't have to do anything now, right? So no glue job to write. You don't have to maintain any Spark script or perform any orchestration. So I have this screenshot from the console. So let me show you what this looks like in a practice. So here is the Glue console. You can see our zero ETL integration dashboard on the right side. You can create a new one by simply clicking your zero ETL integration. And at the top of the dashboard, you can see like how many active pipelines you have. So once you click on that zero ETL integration, now you have to select your data source. You have to define and submit it. And these are various source connectors available. So you can use that to build your zero ETL pipeline. And now let's confirm the data actually landed into our open tables. So the screenshot which I have presented that you are viewing the S3 table, the transactional data is sitting in your open Iceberg table in S3. You are querying it by any engine. No copy steps, no pipeline built. Operational data become analytics ready automatically via zero ETL. And we can watch the integration and keeps the table current. So in this, you can see that this is from the CloudWatch log, which shows exactly what has happened. So there is an initial seed that that brought like some 5,000 record. Then the CDC kicked in, capturing individual inserts, updates, and delete as what has happened at the source. And then on the right side, there is an Iceberg snapshot table that confirms, and we can see append and override operation, giving us full auditability and time travel capability. So this is the power of zero ETL. In minutes, not days. You have the production data flowing into an open, variable, governed lakehouse. That's how we get data in and keep it current. Next, I will hand off to Jayant to talk about governing and consuming it over to the agentic AI perspective. Over to you, Jayant.
Yeah, thank you. So let me bring this slide up and then we can get started. Just give me a second. Okay. Let me know when you're able to see my screen. Okay. So as we spoke about data landing into Iceberg, one of the key components that we want to look at for today is how does this data foundation that we've established, right, over the last few days, we spoke about why Iceberg is important, uh, and then we spoke about the governance layer of Iceberg. We spoke about uh, how catalog federation enables you to bring multiple data into one view. And today morning, Nidhi has walked us through how to easily land data into Iceberg. With that context being set, now let's look at the consumption path, right? Let's add agents into the mix and see and kind of take it forward from there, right? So what does agents do, right? And why does this matter in the context of agents? Foundation models, as you're all familiar with, are limited by what data they have. They don't have access to your data. So they need a strong data foundation for it. And an agent, if you is only as good as its data, right? So if you don't ground it with good data, it's going to hallucinate heavily. More importantly, enterprise data is siloed and technical, right? It was never built or imagined for an AI consumption layer. So what does this mean? You have data silos. If you have a insurance system, you might have policy, claims, billing, and so on and so forth, all in separate systems. A question might come in across these systems. How do AI agent get to it, right? And then text to SQL. The questions that are going to come from an AI agent are going to be more around like text questions, right? They're going to have free from natural language based questions, and you have to translate those to actual data related answers. So, how does that happen? And then right now, we have standards that have come in, right? Like open standards for how do we access the different layers. We're going to look at how that applies to data and data services as well. And then skills, which tells you or teaches you how to get to that data. We'll see how skills can play a role here as well. And then a semantic layer, which basically has the metadata to talk about your data, right? So with these, we look at how to solve some of the challenges that AI agents face today. So moving on, if you were to kind of break up how an AI agent answers a question, there are three parts to it, right? So discover is the part where you want to basically be able to find assets or uh, tables that have information that can help answer the question there, right? So if I'm asking a question related to orders, then do I have a table or a database that holds the order information? How do I discover that? That becomes the first part. Once we discover that, then we want to be able to verify whether that is on the data attributes that we are looking for or on a schema, and then verify whether we can build a join, excuse me, to that specific table, and then be able to build a SQL. And then finally, you need a engine that can actually execute it. And then if as you do this, two things become important. One, a governance layer, right? So though you're using an AI agent to get to the different data points, you cannot let it do its own thing without aligning with the governance principles. So if it is whoever is doing the discovery, that role or that person should have permissions to do whatever to be able to get to it. And then how do we teach the agent to do some of these things, right? So can we use skills maybe as a playbook that teaches the agent on how to go ahead and do each of these things? So with that, let's get into introducing what is a semantic layer, right? So when we look at a table or a column and you just give that as a feature to a LLM, then the LLM has to have potentially all your database and columns in one context, which makes it hard as your table scale. So what do we need instead? We need discovery as a way for an LLM to be able to find the assets that are related to the question being asked, right? So you need some semantic capability, search capability. You need description, good human readable description for columns, not have something like uh, SLSDT, and it means sales date, or ORDDT or something like that. Some cases the LLM might make sense of these columns, but you really need to add good descriptions and keep the LLM grounded on what you're trying to do, right? And then you want to be able to add metrics to kind of define cases where business metrics could mean either defining or expanding a column with some additional descriptions, or maybe giving an LLM a way for it to be able to derive business metrics by a combination or aggregation of columns. Then what is the underlying data behind these columns? Not in all cases, but when you have an enumerated field or you have a field with these values, adding that sample data and profiles does help. Then how do these tables link with each other? Is there a way we can add context on keys by defining what those keys really mean, right? And then finally, any governance context you want to add to these attributes so that the data classification is understood. And then maybe that can also play a role here. So a semantic layer basically helps serve as the bridge between the LLM and the actual data sets that are residing below, right? So with that context, how would an architecture with this context being added look like, right? With AWS services, if we were to kind of go around it. So as we spoke about, an agent first needs reasoning for it to be able to understand what the user is expressing. We want to teach the agent what to do, right? Maybe we give it a skills library to teach it on how to go and discover data, how to execute queries, and so on and so forth. And then we need a way to be able to orchestrate that whole flow. And now how does the agent interact with the different layers, right? We want it to use the AWS MCP server. So AWS MCP is a recently announced announcement where you have access to a lot of the AWS services. So you can check that out. And what it gives you an ability is to hit the different layers, right? So from a catalog perspective, you have the Glue Data Catalog or the SageMaker Catalog. And you have now some semantic search capabilities that we will look at. And you can also enhance this data with Glue Data Catalog with additional metadata as well with some recent announcements. So this gives you a foundation, right? And this is getting expanded. You might have seen a new service that is getting launched called AWS Context that's going to come back, and there is a context-based accelerator as well. So this space, we already have
ब्लॉक
capabilities
कर
and is evolved.
मैं कॉल पे हूँ मैं कॉल पे हूँ
Okay, I think
वह
somebody.
रखूँ
I'm gonna go
रखा
mute
रखा
them. Okay, hold
Yeah,
on.
no worries.
Yes,
Okay.
go ahead.
Yeah. And then we have the data plane. This is the place where we actually have the S3 tables, right? This is where we have Iceberg or any of the other underwriting assets, either directly or through a federated way. So when you looked at yesterday, this is the reason why we spent a lot of time on data interoperability and spoke about how to bring all of these federated resources as well into the data plane so that now it all becomes available to the agent. Then we have the governance. This is a horizontal layer. Anything you do has to align with governance. If you do find assets or you want to search catalog, you cannot access columns that are not discoverable by the role or the permissioning that is tied to that agent, right? So the governance brings all of these together. So with this architecture, just kind of giving you a view of it, to simplify it, your context layer is just going to provide semantic information or metadata to how to access the data, right? And with that being said, if we were to translate this to skills, and then there is now a recent announcement, and I'll again show these as a part of a demo as we will run through this a little bit later. What we have now is prescriptive guidance on all these three layers, right? How do you find your assets? How do you query your data lake? And then there is also an asset on how to explore your catalog. So you can start with exploring catalog as an optional capability, but then once you identify where you want to go with, you basically identify the data lake assets and query the data lake. And each of these have different MCP operations. So what does a skill do? It basically is a guideline. It's almost like a playbook teaching an agent on how to do an operation. So when you look at something like find data lake assets as a skill, it teaches you how to use search assets, which is a semantic search, get asset, and then get some of the column or table level metadata from list iterable forms over the catalog. And the query my data lake, for example, will teach the agent on how to go back and do a query execution and go against Athena, right? So this is a view of how AWS is not just talking about, hey, okay, we built you an MCP, but we are also providing skills that can be used as a reference or a playbook for the AI agents that you build to basically get to the underlying data. And as usual, lake formation is always there to kind of bring the governance together. So now we are going to look at close to a 5-minute demo. And this demo, which just to set the stage, is an e-commerce application. And what this e-commerce application has is a few tables, right? Just 7 tables in this example. And why do we have this? These 7 tables just give you a view of a specific database. And now what we are going to look at is how, if we were to build through these skills that we just looked at, what is going to happen. In this specific example, I'm going to use strands which is an orchestration framework to show how the agent works. But let's get started. I'll walk you through the demo. So this is the tables, and if you look at these are within S3 tables defined. And one of the things interesting you will see, you can add column descriptions and the comment column through Iceberg natively. So it's a part of the Iceberg metadata directly. And if you look at it, these tables have been defined with column names and column level descriptions as well, right? So with that context, let's continue and look at the other pieces within the demo, all right? The first part is the skill. So if you look at Agent Toolkit for AWS, it's a library which gives you the skills that are defined. And if you look at these skills, they teach you how to go back and discover assets that are within the uh, AWS ecosystem, right? So in this skill, basically it teaches the agent on how to go to a specific task, right? And then here we have the ability for it to do the three operations, right? Which is search asset, get asset, list iterable forms, right? So now this skill basically enables the agent to be able to search assets, get asset, and then discover any other additional metadata that is tied to these assets, right? Like business glossaries or additional column metadata that you tie to it. Makes sense? So once we look at now, AWS is given a skill for find data lake assets. There is also going to be additional skills. So once you find the assets, you want to be able to execute a query for it. Now here, there is a specific guidance provided for how to get to and execute queries across these engines, right? So now the query data lake is giving you a view on how to do that. And if you go through this skill, it'll have an ability for it'll teach you how to build the query, and then it shows you the supported operations. And if you look at insert or update, it would be shown as requiring user explicit confirmation. So when you're making updates, it requires confirmation or human in the loop to confirm that. Now let's start with the demo. Here, the questions that are getting asked are top 3 customers in California by order value and how many returns they have. So the first thing it does is, and it is using an analyst persona, so the PI should be masked, right? So one of the first things it does is it does the search with the different entities, customers, California and others. And here, what you will realize is the discovery has given it 3 assets, right? There were 7 tables because all we need to answer this question are customer, orders, and returns, right? And the reason why this is important is because out of these 7 tables, we don't need to discover everything. And then the next skill kicks in on how to get to the query execution results. And with that, you're able to see it. And if you see here, the data is masked and you will see the underlying data for each of these, right? So just want to kind of give you a flavor of what this really means. And if you look at here, this shows you some of the business metadata as well, like the table descriptions, column metadata that I have tied in. Now, let's say we use an admin profile to run the same query. What happens differently, right? So now you see some of the PII columns are also getting listed as a part of the discovery of the assets. And now you are able to see the PII information getting listed, right? So this happens magically almost because lake formation is kind of governing that whole piece. So now if I were to just talk about returns for customers made, then for this, you don't need multiple assets. So you now see the discovery has resulted in only 2 assets getting returned. Orders is not relevant to answer this question anymore. So you're not seeing orders come back, right? So now this hopefully gives you a view why semantic search is important and why that becomes important to answer questions that you might have, right? And this demo was built using strands to kind of give you a view on how to orchestrate this whole flow, right? So with this demo, I want to take a step back and kind of go back to one slide and then we'll walk forward again. I just want to go one step back and then show you this view. So now if you look at the demo, I hope it helped you understand how the semantic layer with the find assets, helped it discover it, and then it used to be able to execute the query, and then the governance layer, right? So as we speak about this, this is an evolving field. There are capabilities already, as I showed you, and this is only getting improved on, right? So with that context being set, let's move on to the next slide. What did we all go through now, right? So we went through an end-to-end view of how to build this data, and then we landed the data on an AI-ready lakehouse. Yesterday, we understood what this lakehouse is all about. And then we saw about adding business context and then surfacing those to an AI agent. And what did that facilitate? Intelligent outcomes, right? So that's kind of the whole play on how we were able to get to it. And as you saw with Iceberg, this whole process is seamless, right? Because when you looked at streaming or batch, specifically streaming as an example, you were able to land the data quickly in easy ways into your Iceberg data lake. And then the lakehouse, for example, on S3 tables, helped it have a low management footprint. And then we were able to add context using our catalogs, and then use that context within the AI agent to deliver intelligent outcomes. We will be going through a workshop for that. But one more thing you can also do is there is an internal assistance within AWS, which is Quick. So what does that give you is it gives you an ability for you to be able to surface some of these data assets within Iceberg that we looked at directly, and then be able to answer questions or ask questions through that, right? I'll quickly show you another view of this. So if you look at, for example, you can go ahead and create a data set from your existing schema, right? In this case, we had our 7 tables on our e-commerce application. So you can pick and choose to add an asset. If you want to add reviews, then you can add select, and you can create another data set, right? And this becomes a data set available for your BI tool to do it. So you can either import it into memory, or you can directly query your data based on how you choose to build it. And then once you have that data set, then you can ask queries or chats against whatever you are trying to do. In this case, for the user persona that I have, there are 2 customers with 3 order counts, which basically means that I have been able to not just view my data sets, but also give it access to a internal AI assistant as well, or so that you can surface some of these findings through an analyst role, through a BI and analytics tool within the AWS ecosystem as well. Just wanted to give you this view that this is possible, and you will be playing around with this view a little bit during our workshop that is going to start in a bit, right? With that, I'll transition to the workshop. But before we do that, we want to give a few minutes for some questions, and then uh, we can talk about what we are going to cover through the workshop. But Hari, do you want to bring
Yeah,
up any
sure.
questions that might have come up?
Yeah, so let me take a quick look at the chat window. Most of the questions have been answered, but I think one question, the last one I'm seeing, is quick search only available on Gold? Not sure if I understand that. I think asked by Heba. So Heba, if you can unmute yourself and ask that question.
Uh-huh.
All right. So I'm not sure if Heba. Okay, I'll repeat this question one more time.
Sorry,
The
it took me a second to unmute.
No worries. Yep.
In that last slide,
Mhm.
about 2 minutes ago,
Mm-hmm.
there was a couple back. If you can go back a couple more,
Mm-hmm.
I think it was. There was a note there that said, "Quick can only be used on gold," and I was just
No, where was that slide? Okay. So a quick directly via the native S3. I think this is the part that you are referring to. So this is just an example that in traditional case in a medallion architecture, the gold layer is the one that typically gets used for driving your BI layer for your analyst persona, right? Because you have your data curated and modeled for that persona. That being said, Quick can access any asset that is available provided you do it, right? So if you have a technical analyst who wants to look at data from an operational analysis front, they can build it from the silver layer, expose it, and have that viewed as well. So technically, there is no restriction for you to do that.
And that answers my question. Thank you.
Perfect. Uh, any other questions?
Yeah, we have one more question from
Uh-huh.
Prakashan. The question is the semantic layer memory size same as LLM context window size?
No, the semantic layer, the way to think about it is it's independent in terms of your LLM context. So here, when we talk about a semantic search, it's more like a vector search, and it is delegating that to an engine to do that operation, right? So it is completely independent of your actual vector search or sorry, your actual LLM context. So that's the real benefit of it. So let's say you have a database of 100 tables and you're asking a question. And what's going to happen is the semantic search is potentially going to help you use that context and be able to give you only the list of tables that contain the columns to answer the question asked. So that benefit that it is completely separate from your LLM context avoids you adding noise into the LLM context, right? So then the LLM can only look at the assets. So if you remember the example that I showed you, there were 7 tables, but based on the question asked, we were only providing the LLM context of the 2 or 3 tables that were required to answer the question. So hopefully that helped. I see Ramu has his hands up.
Hi, Ranjan. Can I?
Yeah,
Hello.
go ahead. Yeah, please go ahead.
Ranjan, thanks. Actually, it was a very nice session, and yesterday and today. So I'm right. So my question on the streaming side. So
Uh-huh.
Delta Lake, actually, we are heavy on the Databricks, right? So
Okay.
I
Mm-hmm.
have seen breadth and depth of the Databricks and Delta Lake features.
Mm-hmm.
So on the streaming side, so sorry, streaming latency side.
Mm-hmm.
So but typically, right, Delta Lake handles fast streaming ingestion.
Mm-hmm.
It does quite well due to its linear commit log. Right.
Mm-hmm.
So I wanted to understand the Iceberg, like hierarchical metadata. So right, so this is what my understood the
Mm-hmm.
when I from the yesterday session Iceberg hierarchical metadata.
Mm-hmm.
Right, so just considering the streaming workloads, does it
Mm-hmm.
handle the the same way that Delta Lake offers? That that
Yeah, I can give you a few views on what actually
mm,
happens on the
mm,
streaming
mm,
side, right? And
mm,
how to think about it. So from the streaming side, what happens is there is an option within Iceberg metadata, which is merge on read, right? So what does that facilitate you to do is as it is getting new data in, it creates separate files from your actual data file. So if you have 1 or 2 data that is getting added to a table, for example, right, within the window, then what it is going to do is it's going to create a separate file for those 2 records, right? And if it's an update, then it'll create potentially a delete file and a new file. And then the commit, the write itself will be faster because now you are not rewriting the whole data, but you're just creating these small files. And then the commit will happen. So the write is faster now versus full rewrites. which were expensive operations. So originally, when copy on write, which is the other format, is done, that was not very helpful for streaming. So Iceberg started supporting merge on read, and that made that faster. So that being said, what also AWS offers with S3 tables is managed compaction. So at some point, as these small data files grow, you want to compact them such that you don't uh, uh, make these too many small files and add overhead on your read operation. Because what happens with the merge on read is that the read becomes expensive, right? Because it has to merge all these files at the read operation. So S3 tables or Iceberg compaction will generally help relieve that pressure on the read side. So that's how it works. Merge on read on the right side, and then uh, compaction to relieve the read pressure. So with these two capabilities, what actually happens is you have a reasonably good breakdown of what happens.
Yeah,
Okay,
just
got
to
it.
add to that one, I think in short, as you stream, you have these two options: merge on read or copy on write. Copy on write, think of it more like a mini compaction that you run. It takes a little while, but it makes the read side easier. But the merge on read, you're kind of pushing that effort of kind of merging those small files together, reading them to the query part, like the consuming application side. So you have both these options. But again, I think that's a very good question. So I'm not really familiar with the Delta streaming into Delta. But again, these are the two levers. These are the levers that you have on Iceberg, merge on read and copy on write, to kind of make your queries performant, or you have your writes more performant. So again, there's a little bit of a trade-off here, but again, that is what it is. Yeah.
Uh,
All right.
uh, uh, Thanks.
Yeah, go ahead.
I have another one question maybe. So on the governance and right governance side,
Hmm.
the industry is actually moving from the table formats to catalog, right? Catalog level, right? So,
Correct. Hmm.
with the Apache Polaris
Hmm.
it has like top level object and the Databricks pushing Unity catalog.
Hmm.
So, how does this Iceberg community like ensure that Iceberg REST catalog API remains like vendor neutral standard? For like just think about the cross engine access control or multi-cloud strategy. Like,
So the as we looked at yesterday briefly, right? We had the
mhm,
catalog federation, for example,
okay.
now that facilitates, for example, you to be able to read data assets that are in Iceberg on from Databricks, or whether you have data assets that are in Iceberg on Databricks on AWS, right? Using the catalog federation. So it depends on where your consumption layer is going to be, but the data itself being in Iceberg allows you for that easy REST catalog based integration across these providers and doesn't lock you in into a data silo.
Just to add to that one, okay, so you're right. So every Iceberg implementation needs a catalog, right? So whether you bring your own catalog or whether you are using like a more like a managed service, in case like Glue Data Catalog, it's a managed service. It's not truly open, but you have this option of bringing your own open catalog like Polaris or Unity. There is a open source version of Unity and Polaris. So you can always bring this one. But for maximum interoperability, as long as these catalogs support these Iceberg specification on REST catalog API, right? So Iceberg community or Iceberg maintainers, they have specified this spec on how the catalogs can interact with each other by exposing Iceberg Catalog API, REST Catalog API endpoint. So it doesn't mean that all catalogs have implemented it because that's a spec. But in case of Polaris and Unity and Glue Data Catalog, they have implemented this spec. They have exposed this REST Catalog API endpoint. So that's what makes the data interoperable when you kind of exchange and when you kind of catalogs talk using these endpoints. Does
Yep.
it kind of answer your question, Ram?
Yes, yes. Yeah, actually, so I'm from the Delta, right? Delta IO Databricks side, right? So I from
Mm-hmm.
the yesterday I started looking into the Iceberg capability.
Mm-hmm.
So and it was very nice, and even I have to. We cannot learn in 1 or 2 day, right? So I
Of
need to
course.
practice. Yeah, yeah. So, but
Yeah.
looking at the the high level, so I do have some light on the iceberg, like, right? But I wanted to maybe like because Databricks offers so many features, the Delta.io, liquid clustering, file maintenance, and commit log,
Mm.
many things. There are many things in there, but I feel it is same as the what are the file operations, file maintenance. I hope that Iceberg also offers the same way.
True. I mean, if you're talking about liquid clustering and all those
Yeah,
things,
correct. Yeah,
yeah.
yeah, yeah, yeah. Liquid
So
clustering and
So those are
that also I
those
did
are
it.
some of the proprietary
Mm,
offering from Databricks.
mhm,
Again, you get liquid clustering on your Delta implementation. I don't know about the Iceberg
I think
implementation,
mhm.
but again, that's more like a Databricks proprietary service. You don't get it if you're not on Databricks. So, but with Iceberg, I think the closest that can get you uh, to liquid clustering is the Z ordering.
it's your
Yeah, the problem with the busy ordering is it's not really continuous like liquid clustering because there is no compute attached to it all the time, right? So, but with Databricks, you always have some compute attached to it, meaning there is some
Okay.
background process running constantly to kind of Z-order your data, or like in a multi, if a query patterns are not known or dynamic, then obviously you need to reorder your data, reorganize your data. So liquid clustering makes it more efficient by looking at your query patterns and reorganizing this data. But in Iceberg, the closest that you can get is Z ordering.
Yep. So it's
Mm.
kind of something similar. The only thing is it's not going to be automated for you, right? So you look at your query patterns and then you define the Z order based on what you find relevant, right? So from a performance standpoint, you have sort or Z order, and this kind of gives you the ability to cluster, similar to what Databricks does behind the scenes. But the only thing is you get an opportunity to do it versus whether that is automated.
Yeah. So I know that we are on top of the hour for the workshop. So maybe we have time for one more questions. If anyone has any questions, maybe this is a time for you to ask. Okay. All right. I'll count to five and then we will move forward. One, two, three, four, five. All right. So I'm guessing no more questions. And if there are any questions in the chat window, we will answer them. That said, we will move forward. But again, thank you so much, Jay. I really appreciate your time. So I will, with that said, like I will now ask Ricardo to come online, come on the camera. But again, folks, we do have a small bad news for you. I know that we are all here to kind of know more about our offerings, how to build these lake houses on AWS, and you probably want to kind of try this yourself. But we just realized that some of the accounts that we provisioned for the lab, they're not working as expected. We just noticed that one, and it's such a bad news for you, I know. But again, it doesn't mean they're totally crippled here. We do have about 20 accounts that we can work with. So my sincere ask here for all of you here is that whoever thinks that, okay, I can just do this little offline, maybe tomorrow, then what we can do here is today you can spend next 15, 20 minutes just going through what this workshop is all about, understand the workshop, how to do this workshop. But actually, we will be sharing the link to the workshop a little later today once we kind of correct those issues. We will share that link to you and you can go through it offline. Like, that is one option. And the second option is that, hey, no, I rather want to do this workshop along with us. Then probably we need to reschedule this workshop, or maybe kind of schedule this one more session just to do the workshop. So again, I just want to see what you think. Again, if you think that, okay, you can just spend the next 15-20 minutes here, and then, you can do this workshop or the lab a little later tomorrow once we share the link to the workshop. Please, please put your name here, um, in the chat window. You just mention
Yeah.
work offline. So you can just mention work offline. Okay. So I see some folks that saying that work offline. Great, 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 great. Okay. Okay. I see that some of you have mentioned work offline. Great. Thank you so much for being accommodative. I really appreciate it. So what that means, if you want to work offline, we will share the link to the workshop, maybe end of day today, or maybe Monday morning. We will share the link once we correct those issues, right? And those, okay, I see about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, again, looks like half of them are okay to work offline. So I sincerely appreciate it. Thank you so much. And those who you want to do this one today, we have about 20 accounts already set up. So those who wants to do that, Ricardo will be sharing the link in a short while. You just need to click on that link. Those who said that they are okay to do this to do this offline, don't click on that link. Okay, that Ricardo is going to share. We're going to share that new link to you maybe on Monday. All right. So that's it. Ricardo, over to you.
I was talking on mute. Sorry. Can you hear me now?
Yes.
Okay, give me just 1 second to go back here. I think that you can see my screen, right? Just to be sure that
Yeah.
I'm in the
Yes, we
right
can.
place. Okay. All right, cool. So let me share that with you. We have this link here, as mentioned by Ari. So this is the link for the takers, for the ones that are going to take right now. Hari, I think that I can walk them through without taking one account. So I will not consume one account. Seems good?
Sure. Go ahead. Yep. That
Okay,
sounds good.
cool.
Yep.
Again, this link is just for the ones that are going to take right now. The ones that will take offline, we are going to send you a separate link like this.
Yeah. So Ricardo has posted the link in the chat window. Only those who wants to take this now. We have about 20 people who can take this now. So click on that link, and whoever said that they're going to do it offline, don't click on that link.
The public link for the workshop, good. Just a second. It's in another. Let me get that here. This is not this is the one. Let me get that here. I'll send this is the. But even the ones that are going to take the workshop offline, we are going to provide you accounts. So wait a little bit. So this is the open public link that are going to bring you to this page. All right. But those that will be taking the workshop with us, you should see a page like this. All right. I would say wait. I see people asking about the public and something. Please wait for the other link that we are going to send if you are taking that later. Just if you are taking that right now, event is at capacity. Let me see here. Give me just 1 second. Hmm. Give me just 1 second.
So let me see.
Why I see denied? Let me see if I can. Let me try one thing here. Let me see. Why are we getting denied? Hadi, any idea? I don't think
I'm
so.
checking if
It's a
any.
allow.
Do you want? Okay, so maybe it could be allow all, I guess so.
No, it is in allow all, but I see just one people that got access, and all the others are getting denied.
Yeah, so weird.
Someone already sold the invitation. Sorry. Let me see one thing, because the teams here, I see all the teams available. Just one account was taking. Just one person could take the account.
Yeah, let me see what's going on. Give me a second.
Okay.
Can you try to log in, sign into the workshop,
Okay.
Ricardo?
Let me try. So maybe one-time password. Maybe because mine is an Amazon account. Let me see.
Mm.
Yep. It gave me uh to those trying and getting the uh, event at capacity. Were you able to get the passcode or no?
Yes, we got a passcode.
Okay. Let me see one thing here on my end. Give me just 1 second. Hmm.
Do they need to plug in the access code?
No, the access code comes with the link that I sent.
Mm-hmm.
I'm just waiting let me see.
Yeah, I just pasted the link here again. Can you try that one more time for those who are not able to get in? Can you click on that link
If
that
I try this, I will not get an account, right? I'm just
uh,
afraid of
j- just
getting one
hold.
account.
No, just hold on. I think if you do it, I think you will burn an account.
Yeah. That's the point.
The
Yeah,
I don't want to
new
do
link,
it.
the new link posted, I was able to get in.
Okay.
yeah. So, yeah, I think the 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 link that you posted seems to be incorrect, Ricardo.
Okay.
Yeah.
Okay, cool. Sorry for that. So let me see here. All right, I see many people as being assigned right now.
Hmm.
So we still have, let me see.
Okay, so I see like 9 people joined or able to get in.
Yeah, we still have few accounts. 1, 2, 3, 4, 5, 6, 7, 8 at least.
Yeah, awesome. Awesome. If you want to take it now and then you still think you're not able to get in, I would ask you to just unmute yourself and then just say it out loud.
Yeah, I see only 12 people taking accounts. We still have
Hmm.
some accounts if you would like to join.
Okay, awesome. All right. So again, one final call. We have 8 more accounts that 8 more folks can just do this workshop today. So if you want to do this today, just click on this link that I shared recently. I'm going to share it one more time. Click on that link. All right, so maybe we can get
Sure.
started. And
Yep.
again, thank you so much for everyone who so nice and accommodative today. So we're gonna share those links to the workshop again by end of day today, or maybe worst case scenario on Monday morning.
Yep. I have we now have some accounts here. Should I take one to go with them? I see.
Go ahead, Ricardo.
Yep. I think that would be better for the people to follow, right?
Yes.
Okay. Let me see one thing. Give me just 1 second. So let me also do this. I think that it will send me another email. But let me try this one anyway. Yep. I'll need to wait the new email. Hari, are you recording the session? We could also share the recording for those offline.
Yes, we're gonna record this session, for a while, not the entire workshop, but at least for the first 15-20 minutes until you're done with the walkthrough.
Okay, cool.
Mm.
But we need to start with the prerequisites. So I will start on the prerequisites session, and then after that, I'll go end to end and explain everything. Okay, because the first prerequisite takes 10 minutes, up to 10 minutes to finish. So just let me see if we still have accounts before I take. Yes, we do. So I'll take one. All right. So first things first. Oops. Yep, I didn't get one. Let me try one thing here. Let me get the.
Use my link, that one I
Yeah,
shared.
yeah.
Mm.
This is what I'm doing right now. Yep, done. All right. So this is the screen that you're supposed to be seeing right now. Please let us know if you are not. Okay. As I mentioned, before going end to end on what we are going to do, see here prerequisite setup. Okay. So this is something we need to do. We need to go to the SageMaker and create a SageMaker Unified Studio beforehand. So to achieve this, we need to click on Open AWS Console here so we can have the AWS account logged in, as you can see. So now I'm sure that I'm using the AWS, the right AWS account, because I see here workshop WS participant. So this is the role that you should be seeing. If you are logged into your company's account, you may open your company account. We don't want that. So be sure that you are using this type of account. And once you have this open, we can get back here and click on Amazon SageMaker, right? Once we click on this Amazon SageMaker, we will have the steps here. So we need to click on Get Started, okay? In the setup page, we are going to leave everything as default and click Setup. That takes 5 to 10 minutes to set your Unified Studio environment properly, okay? Let me try to reopen that. All right, here is. So this is the screen that you should be seeing. As I mentioned, we should click on Get Started. By clicking on Get Started, we are going to see a set of options. We don't need to change anything. Here on the bottom right side, we have a Setup button. All right. So we just click this and wait this rocket to finish his part. So it takes 5 to 10 minutes. And now I'll be going on the steps with you. Please let us know if you're not being able to see this screen, and we can help you through the breakout rooms. I see someone asking, these accounts are error-free or these are having issues. We hope this to be error-free. Usually we can deliver end-to-end, but if you have any error or something, let us know. We have breakout rooms for you to join, and someone from our team will help you on solving the problem. Okay? All right. So I'll pause here. Does anyone have any issue or something? Come to the mic and please let us know. All right. So while this is being set it up, let me go this end to end with you. So our workshop here today will mimic a company, right, which is building a modern data lakehouse architecture on top of S3 tables and Apache Iceberg. So in this workshop, we will be able to see, let me see here. Yeah, we will be able to see, for instance, how to acquire some data, for instance, from MSK, which is our managed version of Kafka. And through Amazon Data Firehose, this will go directly to S3 tables as the credit card information. Let me try to increase this to be easier to be seen. I think that's better. The second part of your first lab will be converting a CSV data into Iceberg data. So the first lab will focus on how to transform some data, some source data into Iceberg. More than that, the lab 2, we are going to see how to join this data using Amazon Athena and creating a different table in our S3 table catalog by using Athena join. Lately, we are going to see how to create also an aggregated version to be our consumption layer. These are the 3 steps that we should follow today. Although you're being able to see, let me go back here. Yeah, you should be able to see that we have two extra labs here. One is how to consume this gold layer on Amazon Quick. I don't believe that we're going to have time to accomplish this today, but the accounts will be here for you, so you can test it. And also the 51, which is also optional in this case, for the understanding the best practices for table maintenance and optimization in production. All right. So again, in the first one here, let me see in my case here if it was already created, yet still spinning. So again, we are going to focus here on the first part. I will be making also the steps here with you. So I'll go step by step with you and show in my account. If you have 2 monitors, I think that would be a good way for you to follow instead of getting always back to the step. But anyway, I will follow you in all the time. For those that are going to take in this later offline, as you can see, the workshops does bring to you the steps, and more than steps, sometimes we have the screen share and the screen share will provide you the sequence of everything that you should do. All right. I'll pause here to ask if anybody has any question or if you're facing any issue, please let me know.
Yeah, you have ability to unmute yourself. So if you have
Yes.
running into any issues, please feel free to unmute and then interrupt us. All right, go ahead.
All right. So I'm still waiting the SageMaker Unified Studio to finish. Yeah, in my case here, it already finished. Not sure if you guys also have finished, but just to get started, so if you'd like to see the way that I'll be doing this first, so as soon as it's ready for you, you should click on Open, right? This is going to open the SageMaker Unified Studio UI for us. In the SageMaker Unified Studio, for those that doesn't know yet, the SageMaker Unified Studio is a front end for analytics that we are building for you. As you can see here on the left side, we can connect to different data, some repositories, create some connections. Also work with notebooks and workflows, visual ETL, process data with AI ML. And for the reason of this workshop, we're going to use the query editor. I just like to highlight that it will offer to you a new version. Please don't click try now, click later. But if for some reason you have click on try now, right? You can come here at any time and go revert to a classic, revert to a classic editor. All right. Why I'm asking you to keep on the current editor, not the new one, because all the steps here and the screens are still for the current editor, so it's easier for you to follow. All right. So for this first one, we are going to see the data. We are going to see the data, how it is, the computed data that we have, the CSV data. So here in the SageMaker, we are able to open the catalog. So through the AWS catalog, we can see this schema CSV customer. Okay, so I see here that we have one table. The thing that we need to do is to click on the three dots and click on preview data. Right. So again, for those not yet fully familiar to SageMaker Unified Studio, as you can see here, the first choice is Athena, but we could also have some other options here as Redshift and other engines available to us. So following the step here, you can see that the CSV data that I have, this is a preview for the CSV data, right? And following the steps, we also need to verify, this is just to verify our CSV data. And now we need to verify our Kafka cluster. To verify the Kafka cluster, we need to go to the MSK UI. You will be able to see the Kafka cluster here, right? And we also will need to get some information from the CloudFormation, the flow ingest and flow egress, right? Actually, we will see that it created. I can show you here as well. So on the console, for instance, I can go to the MSK. So if I type here MSK, it brings me to the MSK screen where I'm able to see the cluster. So this is my cluster. Again, I'll try to explore this as much as possible. So you can see here the cloud metrics for the cluster. And from the time that we have created these accounts, you are able to see that we already ingested some data and we are using that in order for you to have data to be consumed, right? As you can see also here, on the topics, we have the two mentioned topics in the steps. So just for us to know what we have right now. So as as far as you can see here. We also need to take a look on Firehose. So Amazon Firehose, the Kinesis Firehose, data Firehose, we just rebranded, is a streaming application that we have, which is able to have as a source, for instance, something like Kinesis data streams or SK, which are our options for streaming, and send this directly as a destination to Apache Iceberg tables. So this is an easy way for you to convert automatically data from our streaming to S3 tables. The Firehose works by configuring a minimum buffer size and a buffer interval, which means that whatever reaches first here, 60 seconds or 1 megabyte of data being read, the Firehose will flush the data into the Iceberg tables. So again, this is the easiest way to send the data from streaming to S3 tables table, right? So as I told you, we already verified the streaming, and I already mentioned to you the buffer hints here. Also, we have a way to see the transaction table. So the transaction table, as we are using Firehose to send this to S3 tables, we are already able to see this. So if I go here if I come here to the SageMaker Unified Studio, right? We have in S3 tables catalog, not this one, S3 tables data catalog. As you can see here, we have the databases for the bronze layer, gold layer, and silver layer. And inside the bronze layer, we should have the transaction events. So this here, if we go to preview data as well, so this here will show you data that has been acquired by Firehose from the streaming to the table itself. So let me change this. So let me add that as SQL here. So just for you to have an idea, select. Let me run a count, actually a star from Iceberg bronze dot transaction events. So with that, we will be able to see which data we have in this table. See? So this is data coming from the streaming, through it's through Kafka, data Firehose, and then landing in S3 tables catalog as an Iceberg table. All right. So this is the first part to verify the sources. The second one is where we are going to transform the current CSV data into Iceberg data. So one thing that we need to do is first create the table, all right, in the bronze layer. So back here, I'll add another SQL here. And as you can see, this is the database that I'm using, the bronze one. So as I'm using the bronze and I put the table here, I'm able to create that inside the S3 tables catalog. And also you will be able to see that the table type is Iceberg. So as soon as I run this, we should be able to see here the second table. So that this ends, see table 2, and the table is already here. I'll add another one. And the next step is loading the data from the CSV table. As any other engine which deals with the SQL, we have an insert select. So this is pretty straightforward. I'm inserting in the bronze layer from the AWS catalog, CSV schema, and then the customer data. So I just need to copy this and paste, right? But before that, just to show you something, I can do like this. So select, start from customer master. All right, if I select this and run, I should be able to show you 0 rows. All right, see, 0 rows. Here, I should toggle and remove the limit 100 before running. So I'll be running this. And once this run, I'll get back here and run a count. So as you can see, the data was already ingested. And now we should be able to run this count. And you will see that we have loaded data inside our Iceberg data. See, 28,000 plus records in this, right? So as simple as an insert select, we could read from CSV to and move that to an Iceberg based table. That would work with Apache, Apache Parquet, that would work with any other type of data that you have already exposed in your Glue catalog to be converted into a Iceberg table, for instance. All right, I'll pause here and ask if you have any question before I move on.
Anyone
right.
has any technical issues, like, not able to get into the workshop, or not able to follow along?
Am I too fast, or please let me know.
I will assume that we are good.
Yep.
Okay.
All right, so this is the data that we have. So moving on, as we can see here, the third step is we are going to validate the data that we have in the transaction data, right? And we also can, let me do this. So I will copy this here, add a SQL, and start running this. In the meanwhile, I'll go here and get this one as well, copy, add another SQL, and paste. One thing that is interesting to see here, see, in this query here, we can see the transactions, right? So we can see all the transactions. Here we have an idea when it was the earliest transaction. So my streaming, when it started, we started consuming the data from streaming, and when we had the latest one. So we have here August 7, 1740, which is UTC. So it was 2 minutes ago. Let me see if I can run that again and see something being updated. Yeah, see, 1741, we have a little bit more than here, see? So the data is coming from the streaming, and every 1 megabyte or 60 seconds, we flush the data into the Iceberg table. This threshold is the minimum possible. We set that for the workshop because of the size of our data. But at your company, in your real world scenario, you can set higher time or amount of data at least to avoid small chunks in your table. That concludes our first lab. You have any question? I'll pause here to wait for some questions or comment or something before we move on. I see some questions in the chat, but those were already responded as far as I see.
So I think there is one question about
Sure.
is Amazon SageMaker Unified Studio
Mhm.
free to use?
Yes, there's no charge to use the Unified Studio. Although you pay for instance, when I'm using Athena to create something, I'll be charged by the usage of Athena and whatever I use as an engine.
Right. So for the UI experience itself, that's
Yes,
free. There's no
the
cost
UI, yes.
associated with that.
Yes,
Um,
but for instance, if I create a AI model or something here, I'll be charged by whatever I'm creating.
Perfect. And there's one more question, Ricardo. I think what's the difference between SageMaker's Unified Studio and Glue Studio?
Oh,
Um,
you want to take this one? Go ahead.
yeah, sure. So yeah, so I think I kind of responded in the chat window,
Mhm.
but think of SageMaker Unified Studio as a single pane of glass that kind of brings data teams, analytics teams, and the AI teams together so that they can collaborate in a single window or a single pane of glass. So that's what we were trying to achieve with SageMaker Unified Studio, right? On the other hand, Glue Studio, think of it more mainly for your data engineering team. So, or maybe they can also be used for, business analysts for a visual way of kind of preparing your data. So they have this nice interface where you can kind of drag and drop stuff to kind of build your data pipeline. So that's what Glue Studio offers. But again, um, Unified Studio is much more comprehensive. Everything that you could do with the Glue Studio, you can also do with the Unified Studio. Think of Glue Studio as a kind of part of Unified Studio. So yeah, Unified Studio has much more to offer than a Glue Studio.
Yes.
Yeah.
As far as I know, the Blue Studio offers, sorry, the SageMaker Unified Studio offers a little bit more, although the usage would be similar. All right, can we move on? Any other question or issues? Do we have anybody on the break rooms, buddy, or no?
Looks like no one raised any concern, so I'm
Okay.
assuming everyone's good, so maybe we can move forward. Unless I'm
Uh,
not able to hear anyone or anyone, you think that you're not able to unmute
yes.
yourself or at least
I'll
like
ask.
post a message in the chat window.
Yeah, I'll ask the takers, the ones that are taking the. Can you please send us a thumbs up or something at least to know that you are okay on the. Thank you so much. Awesome. Thank you. Thank you. So this is our again. This. Thank you so much, guys. So moving on to the lab number 2. Okay, so we are going to unify all the customer transactions, which means that our data engineer here will create a pipeline to join the data created in the previous step. As I mentioned that to you, we are going to use Athena again, but this is again just because of the workshop. Let's say that you are a Redshift user and you'd like to use Redshift to run exactly the same queries. That would be possible because Redshift can also access both the Lakehouse and the S3 tables. So through Redshift, you could also do this. Can I do that using EMR and the Jupyter Notebook or something? Yes, you can do it. It's always important to let you know that many options are available, and more than that, it's not about being right or wrong, but for again, if you have already Redshift or if you are EMR user or something, that would be possible. Here we are using Athena and SageMaker Unified Studio, mostly because we'd like to show you this tools, right? So this again, back on the SageMaker Unified Studio, all right. I opened a different uh, query notebook, right? The SQL notebook here. And as you can see here, we should choose the silver Iceberg FSI Silver schema to start our Silver layer, right? So everything started by creating the table. So I'll copy this. And again, coming here, as you can see, this is on the bronze, right? As I created this one, it should come, let me move. Yeah, see, it should come with the one I'm already using, bronze. So pay attention and move that to silver, all right? If you don't change that to silver, you'll be creating everything on the bronze layer still. So as you can see here, no data because we don't have anything. I will create this table and soon we should see the table here automatically. So the table was created and see, we have one table and voila, the table is the table that we just created. Moving on with this. So we are going to populate the table, right? Just one thing here, we'd like to highlight this table, combine all the customer data. So it creates a unified vision of our customer data. There's a hidden partitioning here. This is partitioned by the day in the transaction timestamp. For those not familiar to the hidden partitioning, we should talk about that a little bit more later, okay? But just for you to know that at this point, we can say partition by, okay, the day for performance in this case. And audit trail here, we have the data source that tracks if the data comes from batch or streaming, which means that when I join the data, as you can see here, so I'm adding the data when it comes from the Iceberg bronze transaction events, that's batch. The other ones will be from the streaming. All right. So let me copy this part here and place in a new SQL. All right. So I'll run this and create some data. Again, remember to remove the limit 100 here. So this limit can be used, right? So I can run this. Let me go back and pick the next one. I'll pick this one, which is the data validation, right? In a meanwhile. So while this is running, let me see here. Where is my screen? Yep, here it is. Let me add the validation here. As you can see, the data was ingested and I will validate the data. As you can see, real quick. So we have the first batch with 100,000 rows and 27,000 unique customers. And here we have some other information, right? So this is the way that we will batch the data, right? Something similar on what we have here. And after that, we will start exploring some features. Let me see one thing here. If I didn't miss anything. Yes, no, everything is fine. So now we are going to explore some Iceberg features, right? Scheme evolution, hidden partitioning, snapshots for auditing. So this is the time travel and things, and time travel. So as you know, one of the main advantages of Iceberg is to offer the transactional files, so we can work with that as a asset database or something like this, right? So what we are going to do here, we are going to add some data, merge some data all right, and bring some ACID compliant uh, uh, operation on top of our tables, right? So as you can see here, we will be merging on the table on silver, right? And we are going to say that, hey, from the transaction table, right, join with the customer master table, also in bronze, and whatever we have the ingestion timestamp bigger than the current timestamp and 5 minutes, right? When match, we can update in case of update. If not, we insert the data, right? So these are the what we are doing here. And from that, let me go here, copy. I'll add another SQL so we can keep the history of everything that we are running.
Yeah, so I mean, I want to interrupt you here, Ricardo.
Sure,
We
sure.
do have a question in the chat window from Shub. Shub, do you want to unmute yourself and then ask that question?
Yeah, thank you so much. And this is very helpful. As you can understand, all these tools are a little overwhelming for someone who is not very familiar with AWS. I just wanted to have one question. Like, this is all
Mhm.
visual, right? But I have been like fed on GitHub and doing change control using Git actions and stuff. So how does this thing fit in? If I'm a developer and I'm writing all these queries here. Can you tell me exactly about how in a development environment this integrates, how I would be moving it from one account to the production account and stuff like that?
Okay. Uh, in cases like this, you should be running, as you can see here, you're logged in using role, right? So I'll try to keep it simple, although it requires some configuration, right? The role, if you want to use that, for instance, here, we are able in one account to create uh, data in a create tables on top of data in a separate account, or even be able to see data from, for instance, Glue catalog in a separate account. In this case here, we have access only to this current account. So as much as you can share your tables, for instance, from production, and have at least one role that will be, that will be able to move data from insert select and ingest into the target account, which is a different account. This is possible. So this is not the main subject here, but again, the easy answer is that this is possible, although this takes a little bit more about configuring and being able to go cross account and move data from one layer to the other in different accounts. Does that answer your question?
Partly. How
Okay.
does this move? Like, if this is your dev account, for example, and you
Okay.
have the data, assume you have the data in S3 and all of that is good, but now how do you do the change control or uh, do the deployments into a production environment where you don't have this flexibility
So
of
maybe I'll
getting,
try to answer these
yeah.
questions a
Yeah, go
little
ahead.
bit. Yeah. So again, first and foremost, like what we are doing here is more like you're opening up some kind of a SQL console and then you're typing to your try to run your SQL command and then see that's output. I would imagine this more like a SQL workbench, what we are doing this. But in a real production kind of a setting, if you are really building a data pipeline, what you would usually do here is like you create a notebook and then you plug in your SQL and then schedule that notebook, correct? So,
Yes.
and then when it comes to scheduling, then obviously we do have something called workflows within SageMaker Unified Studio, which are powered by managed Airflow offering that we have. So which makes it easier for you to kind of create a job and then schedule your job, right? And then again, for a code management, obviously you might have written some code. It could be a SQL code, Spark code, PySpark code, or Python code in your notebook. And then what if you really want to manage that code? You want to have a version control around that code. In this case, what we also have is Unified Studio can integrate with your Git repository, right? So you can bring your own code repository or a project repository, integrate with your Unified Studio project. So what it means, like anything that you build within this Unified Studio project will be kind of committed to your Git repository. So does it kind of answer your question? You know what I'm
Yeah,
trying to say? Maybe
yes,
I'm just trying to kind
yes.
of keep it more high level, generic,
No, no,
Yeah,
but
this
yeah.
is
yes,
this is
yeah.
good.
Yeah.
And the glue jobs and stuff that
Mm.
I have used earlier, they would also be available here because I see there are options to build jobs here as well. So I got a little confused. Like, is this like
Yeah.
a umbrella on top of that, where underlying engine is still the glue job, or is this like a new platform altogether?
So what you're seeing here is a query editor. As on the left, we can see under data analytics, you have a query editor, right? So this is one way of for you to kind of query your data. But what if you wanted use something else, right? Like for example, you said notebooks or glue, right? So we also have that ability to kind of spin up those notebooks and then, start writing your code.
Yeah, the
Yeah,
visual
and more than
ETL.
that, as you can see here, we have
Yeah.
the visual ETL and the
ETL.
data processing jobs,
Mm,
which at the end of the day are blue jobs, kind of.
yeah.
Okay, so
So
these are also like the glue Spark
Mm.
clusters. These can also spin up Spark clusters, and I can actually use them.
yeah, so
Okay.
maybe if you can just see, if you see this one, this console is using Athena. The engine behind it is Athena. But if you want to switch that engine, if you just click on this drop down, you also can switch that engine to something else like
Yeah,
Redshift, the SQL engine. But again, if you go to data processing jobs, if you just click on that one for a second, okay. Um, yeah, I'm not sure if you have anything here. But again, when you click
I
on
don't think
this,
so.
yeah. So we didn't provision everything that we really need here. But what you can do is if you see in the middle, there is a notebook, right? So you can create a notebook. And then obviously, when you create a notebook, the notebook itself is running in some kind of a compute, which is like a lightweight EC2 machine. So you first define what machine it will run on. And then for any data processing that job that or step that you have in your notebook, you can attach a cluster. It could be a EMR cluster or it could be a glue cluster. You can attach to, or it could be an Athena uh, service as well. So you can do that one within the notebook. You have this option to select the compute that you want to run your data processing step.
Yeah,
Cool. Thank you.
and
I'll
then
play
and as
working
you
on
can
this.
see here in the
Mm,
visual ETL, for instance, we have some data sources that could be used. S3 is
Mm.
one of them, or S3 tables. Again, Redshift or Glue Catalog, whatever, but you need to connect to those if you have it. Same as some other third-party tools. And here you have some transformation, the same way that we have in the Glue Studio, for instance. You could create visual ETL here and schedule that. Um, but again, this is a demo on top of the SageMaker Unified Studio. I'd like to highlight that the features that we have here, for instance, with the Athena, uh, you could be using Athena UI, or even not sure if you are a user of Python and the SDK for pandas, where you could use Athena or whatever to uh, use SQL in your tables. So with that, you would be also able to join data from streaming CSV, transform that in S3 tables. One thing is the technology, and the other thing is the UI. The SageMaker Unified Studio in this case is more the UI. In some cases, production cases, we should use, I don't know, some customers, they use their own orchestrators and they trigger jobs through scripts and whatever.
Thank you so much. I think this is very
Sure.
helpful.
No problem. All right, so let me see one thing here. So back here, see the merge already executed. So it means that if I run that again, you will see not only batch, but also we are able to see the streaming data. So every time that I run this, now that I've merged data, see, I have some stream data as well in my table. This is just for you to see what data comes from the merge, with which data comes from the uh, from the first load and things like this. But just for you, again, the main idea here is to show you that we are able to insert select, use merge, create tables, move data across tables and across, for instance, S3 standard to S3 tables, and so on and so forth. All right? So in this part here, again, we ran this merge, right? We already verified the results. So we were able to see this, okay? Let me see, this is a different way to see the data. So let me run this here. We can break into more options. So let me run this. And here we are going to see a little bit of schema evolution, right? So actually, sorry, let me go back here. It's loading the results, and we will see batch, see approve, decline, and everything. We can break this into different categories for the query. Now we are going to add some fields, right,
I
to
have a
our
small
existing
question.
table and load this data into.
So looks like we have a question from
Yeah,
Aruna.
yeah, yeah. Go
Go
ahead.
ahead, Aruna.
So I was following the lab along. I don't see a streaming coming when I verify the merge results. So is this something I'm missing, or I have only batch approved and declined transaction status?
Did you run this merge here and you remember removing the limit?
Oh, okay. I think that must be. Thank you.
Try again and let us know, please. Otherwise, we can bring you to a separate room and try to make it work. But I think it should be fast, so please let me know if you are able.
Yeah, so sometimes when you run these SQL queries, you might run into some kind of a weird issues. It might fail. So, I guess like it depends on the character encoding. You might want to remove the first two comments. You see that line
Yeah.
number 1 and 2, you see those hyphen hyphen like those comments. If you run into those weird issues which it doesn't make sense, you just remove those two comments and run them again.
So as mentioned, we are going to add those columns. So this is the outer table that we are able to run. So on top of the table that we are working here in the silver, and that will always add this 5 columns here, right? So after adding this 5 columns, but let me do that here for you, and you'll be able to see. I'll expand this, so you will see all the columns. Notice that we end here on the data source, okay? So as far as I run this, as soon as I run this, we should be able to see columns being added here after the data source. See? So the rewards columns were added here, and they are right now all empty as any other database. So what do we need to do? We need to calculate and update the table to set those columns, all right? So we have this update ready here. So each of the columns will be populated by a specific calculation. And then we have a verification here. Let me run something a little bit backwards just to show this, because I like to show that we don't have anything before we run. So if I run this right now, this should be 0 because we don't have any data for the new columns. So as you can see here, query was executed and 0. I don't have anything. So I'll pick the update, put that here, execute. And remember, this table here has 100,000 rows, so it's pretty fast for the size. So we are running updates and updating all the columns, as you can see here, already able to do it. And now, if I run that again, we will see the calculations, the columns, and what we'd like to see. So see, now we have data because we created the rewards points and some other columns, total rewards and things like this. So now we are able to select our table. Is everybody with me? The person who was a little bit behind, were you able to see the streaming data?
No, I think I got an error when I remerged it. But yes, I just
Okay, after remerging, you were able to see?
no, I didn't see it yet.
Oh,
Yeah.
do you want to move on a
Yeah,
breakout rooms? Someone can help you?
sure. I would
It
continue here and then connect in the breakout room.
Okay.
It's also fine. Yeah.
Okay.
Yeah.
Yeah, go. All right. So that shows us that Iceberg allows us to add, although this is a file and on top of a S3, in this case S3 tables, we are able to add columns, we are able to update, merge, insert, select, all of this, as a database. And again, the main idea is that we are able to use multiple engine to deal with this Iceberg data, right? As Athena, Redshift, EMR, so on and so forth. Um, the next step, we'll talk about the hidden partitioning. Not sure if you are all familiar to the hidden partitioning, but if you are, for instance, if you're familiar with any database, and the database itself on the storage layer, when we create a partitioning or something, sometimes we create a separate table that points to where the data is, or in some cases we organize the storage. For instance, if we think on the Redshift sorting as a partition, it will sort the data in the storage in a way that is faster um, for searching the data. Or even when you have Apache Parquet, for instance, it does create folders for the partitioning for you. Iceberg is a little bit different. What we call hidden partition is that we don't need necessarily to create a folder to be our partition. We create that only at the metadata layer, and we can use any column, for instance, and apply function on top of this. If you remember our partitioning, our table here, the table that we created on Silver, the partition was day transaction timestamp, which means that if I select start this table, I will not see a column with a day, as for instance, I would have if it were Parquet file, because in the Parquet, the folder becomes also a column. So this is why we call that hidden partitioning. Transaction timestamp is a column with a timestamp where our partition is actually the day, but this not necessarily is shown up when we run a SQL, for instance, right? So as we can see here, if you remember, so we have this query, and this query gives us the possibility, for instance, to say, okay, I'd like to query a table where transaction timestamp is equal, and here I'm taking the day from the current timestamp. So that means we are just pointing to the day, in this case, pointing to our partition, right? So if I run this, I'll be using the partition. Let me add a new SQL here. All right. So when I add this here and I run, this is using the partitioning for us. So large tables, very large tables with sometimes millions of rows or uh, uh, billions of rows can be speed up because of usage of partitions. And that's one of the things that Iceberg offers, which differentiates this technology from other file formats or even databases. All right. Any question here, or can we move to the next step? Actually, let me pause a little bit and see if we have any question. I see one here. In S3 tables, manage Iceberg. I assume what compaction planning strategy are users supposed to manage at their end? Or it's fully managed in general, or operation overhead is expected. Let me show you something here. So if we go on S3, open this in a separate tab. So if we go to S3, and here on the left side, we have the table buckets, all right? Remember that we have the database, the catalog, Iceberg FSI Lakehouse, and inside that we have the silver, golden, and etc. Here we have the tables that we have created so far. So the namespaces here, we have bronze and silver. If I click here, for instance, I'll be able to see, sorry, the metadata for the table, which in this case is the who's the owner, when it was created. Also, I can see the schema for the table. And answering your question, here we have the maintenance properties for the table. So to clean up the orphans, to compact the data, everything, you are able to uh, make your changes here. So the owner of the table, the data engineer, or whatever layer of professionals in your company takes care of this. So we can set that, for instance, to auto and keep the files on 512. If I want to change this, for instance, I could put that here 128 or something like this, and choose some different compaction strategies. I can even disable this if I don't want that to be done automatically, and so on and so forth. Same for the snapshot management, as you can see here. So in my case, it's enabled. The maximum snapshot age is 120 hours, right? So everything beyond that, it does get rid automatically for me because I enabled that. Okay.
Yeah. Yeah, there seems there's a follow-up question to that from John.
Oh yeah, go
That
ahead.
yeah, the question is, hey, when you said clean up orphans and etc., what does that mean? What is an orphan in Iceberg or maybe in S3 table? Yeah. Do you want me to answer or do you want to go ahead?
Go ahead. Go ahead. Go ahead. Problem.
Yeah. So again, I think Ricardo has already mentioned in the past, or maybe Nidhi did mention in the morning and yesterday too. So I think most of the operations in Iceberg are metadata operations, right? So as you kind of add and do these data operations like adding new data or updating new data, to make it quick, so most of the time you're creating these new files, these smaller files, and then adjusting the metadata to point to the right files, right? So what it means is there might be so many files, data files out there, which are really not used. The metadata may not be pointing to any of these orphan or these files, which we call them as unreferenced or orphan files, which are really not required anymore. So it is that time compaction process where you look at all these orphan files and then see if there is something that needs to be gotten rid of because it doesn't add any value because it's no good anymore. So those are the files that you might want to get rid of to save on some storage, right? So there's no point having it. So that's basically unreferenced file removal or orphan files removal. So kind of did I answer that question, John? Okay, I'm not sure. I didn't mean when. Okay, so I'm looking at like any more connected to the data pipeline. It means like if you look at this table, Iceberg table, then the data in this table is basically physically stored in some storage. In this case, it's an NS3 bucket, right? Maybe
Yeah.
an NS3 location. So again, it doesn't need to be just one single file. It could be like a bunch of files or objects. Some of these objects mean nothing because these are outdated as you kind of insert and write into Iceberg. So it might create a new file because it has to drop an old file, create a new file, but the file that was dropped no longer needed at all. So those are unreferenced files or orphan files, which needs to be cleaned up on a time-to-time basis.
Yes. Just to add something on top of this, if you see here on my screen when I see the table, although I see the metadata location, even the warehouse location, this is a bucket that you don't have access to because it's a managed storage for you. So everything that you see is the schema, the tables. You can preview the data and everything, so on and so forth, because we take care of everything for you. If you had, for instance, and I'll have an example here in the general purpose buckets. So if I have here, for instance, the table itself, sorry, where is the table? Yes, I think that this is the Tina. Yeah, for instance, see, we have some CSV data here. I can see the data. I can come here and delete a file or do something like this. Even if it were Iceberg data, I would be able to see all the files here, right? And run my own maintenance uh, scripts to compact that everything to get rid of the snapshots and things like this. In this case, as a table bucket, right? When it comes to see the table itself, I don't have access to the files. I don't see the files in anywhere. What I see is the schema, I see the permissions, I see how I maintain that, and I allow the S3 tables to do that for me. By allowing S3 tables to work for you with a compaction and snapshot and something, you will be not only being sure that you are under the best practices most of the time because you are running that constantly, and also you are not paying for unused snapshots or things like this, right? Oh, I see here a comment that you are able to see the streaming data. Awesome, that's good. All right, so back here again as where we were. So that talks about the hidden partitioning. Now we are going to talk about the snapshots, right? So if I come here, copy this, I'll add another SQL. My computer is a little bit lazy. It's Friday, but it's okay.
Mhm.
So here we are going to see the history. So if you are not familiar to Iceberg, when you put the schema and then the table and use the $ history in front of the table, you are able to see the list of snapshots and other information about that table. So with that in mind, we are able to travel in time here, and see how was the data as of a given point in time. This point in time can be timestamp or a snapshot ID, right? In our case here, we are going to use, let me go back here. So for the time travel, we are able to see, for instance, how it was for the timestamp now last 10 seconds. So we are always able to see, that. So if we do this and come here, all right, so this is,
Yeah, I think this is part of snapshots are kind of play an important role in time travel.
yes,
Yeah, so I guess like yesterday, Jay briefly touched base on the time travel feature of Iceberg. Yeah, so again, and if for whatever reason your organization needs to know that, how did my data look like a day ago or 2 days ago, right? So using time travel and snapshots, you can go back in that time, go back in time and then see how your data looks like exactly a day ago or 2 days ago. Um, this kind of helps one to earn trust in your data. You can always know like who's changing, how they are changing, how the data is changing over a period of time. Um, so if you have any questions about snapshots, do let us know, because I feel like this is an important feature that you need to understand. Um,
see if I
okay.
can copy this. I don't think that I can copy this that simple. Anyway, there are some options that we could use here to use the snapshot, but the main idea is that what exactly Hari just told us. So the time travel here allows us to move back in time, you know, and be able to see what happened or the previous without going to the raw data or something like this. For instance, let's say that we have updated some data, so we would be able to see uh, the before image and after image in this case, or something closer to that.
Looks like
Any question?
there is a follow-up question
Yes, go
uh,
ahead. Let me see here.
on
I lost
Snaps.
the.
Yeah, so there's a follow-up
Mhm,
question on snapshots. So, how often snapshots are created? Can you schedule something on those lines? So again, I can answer that question.
mhm.
So again, the answer is yes and no, in the sense you can control how often the snapshots are taken. But again, the control is only very limited in the sense that, okay, every time you commit a transaction to an Iceberg table, Iceberg takes a snapshot, right? So meaning to say, like after each and every record is added or inserted or deleted or updated, if you're making a commit, that means at that point you have a snapshot on that table. But if you can plan it out properly in the sense like, I want to at the end of the day, maybe I want to have a batch transaction, which will kind of batch all the updates for the day and then commit at the end. Then it could be just one snapshot for that day. So again, the
Yep.
answer is how frequently your snapshots are taken. It depends on how many times you are committing. That's the only control you have. The moment you commit, there is a snapshot, right? The more frequently you commit, the more snapshot. The more snapshots, the more storage costs. So you got to be a little
Yes.
mindful as to how many commits you're making to your Iceberg table.
Yep.
So, so again, one thing we could do is like as you have more snapshots, you can have some process run in the background to clean up snapshots. So anything that is older than 5 days, I don't want it. So maybe you can just get rid of those snapshots. That will
Yep.
bring down your overall storage costs.
Can time travel be used to merge two tables? If you mean using time travel query and insert that into a separate tables, or use two different tables with a join? Worker promoter reported to this manager. As far as I know, yes. Hadi, do you see any limitation for that? As far as I know, it's possible.
Can
We
you repeat?
join data
Can you
using timestamp.
can you repeat
For
the
instance,
question?
he's asking if we can create a query that joins two Iceberg tables, and both of them we have time travel associated.
Yes,
Uh,
it
yeah, it's
can be
totally
done.
fine, right? As
It's
far as I
totally
remember,
fine.
yes.
Yes. Yeah. Hmm.
And then we can use that to you know, uh, insert to a separate table or something for your, you know.
That's right. So again, one thing to note with the snapshot is that snapshot ID is automatically created for you. You have
Hmm.
to remember the snapshot ID. So if you can just query this history, you know, like what's the
Yeah.
snapshot ID when it was taken. But you can also assign a user-friendly name to your snapshot. You call this as tagging. Tagging is giving a name to your snapshot. So, like for example, after a snapshot is taken, you can name it, you know, August 7, 2026. That's a name that you might want to give to your snapshot so that at any point of time you can go back and then look for the snapshot or the data, how the data look like on August 7, 2026. So those
Yes.
are tags. Yeah.
Yeah. And answering a question here in the chat, uh, how history is different from the snapshot. Actually, it's not different. Is that we cannot see the snapshots here. So to see the snapshots, you need to run this with the dollar history, and then you'll be able to see. And I'm able to tell you that this was the create table, this was the first load, and this was the merge. If I run something again, we're supposed to see a different snapshot here because we are not so frequently changing the table. Every commit should create another snapshot. Okay. All right. So moving on, we are here on the, just to be sure, Heidi, we have 30 minutes, right?
Yes, we have about 30 minutes. So what we could
All right.
do is we are in the section 3, lab 3, right?
Yeah, we are good. Yeah. This is pretty simple. And
Mm,
then I may go for, I don't know, some questions or I at least can read the lab 4, which I think that's pretty interesting.
sure.
Okay, so moving on,
I
the next one we are going to work with
Can
the
I
gold
ask one
layer.
question on the snapshot?
Yes, sure.
So if there are like multiple processes writing to the same iceberg table,
Mhm.
how does that iceberg maintain the snapshot consistency?
Yeah, I think Hari mentioned that, but anyway, for instance, if you're not frequently changing your table for instance, let's say that you run one insert per day, you're supposed to have one snapshot per day. But if you are constantly changing the data, the Astro tables will make this something in between 1 and 5 minutes or so. Every given amount of minutes, it should take a snapshot because it's so frequent. Instead of taking lots of snapshots, it will take only one every uh, amount of minutes. How do you have something
Yeah.
to
So,
add here?
is it the question more about if I have multiple writers writing into Iceberg, how does the snapshotting work? Is that the question?
Yes, Hari. Yeah, when it's like multiple processes are writing to the same table. Yeah.
Yeah. So here is one thing to note. Okay. So I guess like you all know by now that Iceberg offers these asset guarantees, right? So again, it gives you those asset guarantees, but at the same time, it won't lock your table. Like when you have multiple writers writing to the same table, no single writer will lock your table. So there is this mechanism called optimistic concurrency control, right? So where you're trying to write something, and then let's say there is another writer who's also kind of trying to write. So if you see another writer trying to commit while the second writer is still it's processing the data. In this case, if the second writer sees the first writer committed already, then the second writer would have failed. It would have restarted it, right? Would have restarted this process. So what I'm trying to say is, at any point of time, only one writer can commit, and the second one can commit after it sees the earlier commit. So there are two commits here, and then it keeps flowing. So every time there is a commit, you take a snapshot, irrespective of who's writing it.
Okay, yeah, I got it. Thanks. Does like Iceberg rewrite all the data or only the affected files when it's creating a new snapshot?
So in this case, if let's say if writer one is trying to add 100 records, and then writer two is trying to update the same 100 record, or maybe existing 100 records, um, you may not run into this problem that I just mentioned, but what if this two writers are trying to update the same set of records? You might run into this problem. So this is when one writer has to yield for the other writer, meaning to say one writer has to redo its entire up job of kind of merging those 100 records, updating those 100 records if it fails.
Yep. And to answer it right, it
Mhm.
is using optimistic locking. So in the case of it being totally different snapshots, meaning totally, sorry, not totally, totally two different set of records, then the data files will be reused as a part of the retry process. It would not have to rewrite the data file. It will just have to reattempt the commit. If there is data conflicts potentially, then that's when that process will have to rewrite the data file. So it depends on where you're writing. For example, if you're writing into two different partitions, and there's absolutely no chance of having the data files being rewritten as a part of the commit retry. Another note, you can also set up Iceberg table properties to control some of the retries, so that when a compute engine that operates on a table sees that, it can respect that and it will automatically attempt a retry as well for you. So just a side note there.
Yeah, thank you. That helps. One small question after that, the like whenever like a new snapshot is getting created, does Iceberg rewrites all the data or only just the affected files into the new snapshot? Like if we see two different snapshot.
Yeah, meaning it is a few differences there, but yeah, it would not. The quick answer is it is going to update the only the data on the impacted files, right? But it again depends on if it is a merge on read or copy on write. If it is a merge on read, it is not going to touch any of the existing files. It'll just create the new files, right? And then the read operation is where that merge will happen. If it is copy and write, it will update the impacted files and as a part of that snapshot, right? And the way it organizes itself is we try to set limits. It's typically at least a minimum of 100 MB per file. The compaction process will try to kind of do that. You can go up to like 500 MB per file, so that you don't have too many small files for the reader to read, right? So if, for example, there is a 500 MB file that has your record and you're doing copy and write, it'll rewrite that 500 MB file. But if it is on merge on read, it'll just do a small file, and then the new record will get appended into the larger data files as a part of compaction.
Okay, thank you. That means it depends on the what command we provide. Okay, thanks.
Yep.
That's good.
Yeah, so I think there is one more question from John. John, I know that you've been trying to understand the difference between, hey, what's this S3 tables and then, Iceberg on S3. I know it can be a little confusing, but I'll try my best to explain it to you. So Iceberg on S3 is more like, think of it more like a self-managed version of Iceberg. So as you probably know by now that every Iceberg implementation requires a little bit of a maintenance, right? So compaction, snapshot deletion, unreferenced file removal. So these are all the maintenance jobs that you need to run for your self-managed Iceberg jobs, right? So again, you create a table and that the underlying data sits on an S3 bucket. But again, at the end of the day, your query performance goes down because there are so many small files which needs to be kind of compacted and you have to run a compaction process. So there's this maintenance overhead with a self-managed Iceberg. What it means is like you need to run a separate set of jobs. As a data engineer, you might want to run a separate set of jobs to kind of maintain those tables or the query performance, which are consuming queries are accessing those tables. But with S3 tables, which is basically our managed offering, What we are trying to do is we will eliminate that maintenance from, we will make it easier by eliminating that maintenance part from, in the sense like we will take care of the compaction, we will take care of the snapshot management, we will take care of unreferenced file removal for you. So you don't have to set up a job uh, by yourself. So there's a kind of answer your question, John.
It seems that, yeah, he says, okay, I got it. Yeah.
Awesome. Perfect. All right.
Yeah, I would use exactly the same,
Mhm.
for instance, as the MSK. Under the hood, it's Kafka, but we are managing that for you. You don't need to put that on EC2, manage yourself. Apply, for instance, the uh, patches and so on and so forth. We do everything for you. So that's why we call that manage. And S3, S3 tables is a managed version of Iceberg, but still the regular Iceberg that you can see everywhere. I see a hand. Yes, Shrahan.
Do you hear me?
Yes.
Okay. Coming back to that locking, if we have two writers and the first one gets a lock, what happens to the second one? Does it fail or no? It goes to the wait.
So, so in the second one, it may continue to do what it was trying to do. Let's say it was trying to um maybe it was trying to kind of process the data, and then at the time when it was trying to make the commit,
Mhm.
it will realize that, hey, there was a previous commit which I might have missed. It will double check. Okay, so if there is a previous commit which it might have not noticed, in this case, it will fail and it will read the entire data, the fresh data again, and then it will reprocess it and then it will commit.
Therefore, when it fails, does it return error code to the client, or it's
It,
all
it,
behind the scene?
it
That
depends
that.
on it depends on how you handle it, the errors. If you're not handling those errors in your beta pipeline, you will see those
Mhm.
failures, but ideally you're supposed to handle those kind of an errors or failures.
What is the lowest level of the locking? Is it record or the whole table or is the file? What what is the locking? If the
It,
first
it,
one
it
if
is
the
at a
first one is in
it is at a partition level.
it's a partition level. Okay.
Correct. Yes. So, I
It's a
mean, if they're writing
partitions.
into two different partitions, the way there is no
Uh-huh.
overlap, you will not really see any of these issues. But if it is at the same partition, the commit is at the same partition where two writers are trying to compete, and this is where you will see failures.
Yeah. And this is pretty interesting if you, for instance, were using your table with a multi-tenancy, which means you have a one table for separate customers of yours, and you have separate writers for each of your customers, which means that one would never bother the other one with locks. So
Correct.
in this case, if you have separate writers and your customers are kind of partitions or something like this, as you are touching different parts of your table, you would be able to uh, run different updates in different
Mhm.
parts of the table and still have asset transaction.
Correct. So I think it's what is important is having your partition strategy right and ensuring you have multiple writers where writers are not really competing for the same partition here or trying to write to the same partition. So I think that should be part of your design,
Yeah.
I would say.
Therefore, if you have
Yes.
a central um, let's say logging table, and then we have the ETL jobs, and each of those jobs can run in parallel. Therefore, all of them they can run in parallel. All of them at the end they will write to the same error log. That can cause locking. Yes.
Yeah, so that's the whole idea. We don't want that locking, so that's why Iceberg
Mhm.
doesn't have the concept of locking.
Yeah.
Okay, but then what happens if I have process A and process B, and then process A completes at the end, it wants to write to the log, and it fails.
Yeah, so it is possible. Again, as I said, like if it is trying to write into the same partition, and
Mm.
then you try to commit, and then
Mhm.
at just before you commit, you check did anyone commit before before
How can
committing?
we
So
check that?
that's because like when you are writing, you're basically using kind of a framework, right? Maybe if you're using
Uh-huh.
Spark exactly know what to do with your Iceberg tables. It won't just commit like that. So before it commits, it double checks like if there are anyone who has committed while I was trying to process this data. So if anyone has committed, that means that there was a more recent update on the table, which I am not aware of. So in this case,
Mhm.
it will result in a failure. And then that's when the Spark will know that, hey, the failure is because there is another write that has happened before mine. So let me just go and then read the data again and then reprocess it and then write it or commit it.
Mhm. Okay.
All right. Okay. All right. So in the interest of
All right.
time, maybe we can move forward.
Yeah.
Mhm.
Let me move forward and finish this part, and then we can open for final questions. So the last part, the lab tree, the customer 360. In this case, we are going to create a separate table in our golden layer, right? And also populate this table with some uh, functions, which means that this would be the gold layer could be seen as the previous named data marts or summarized data and things like this. So this layer will be where we could, for instance, plug some reports that doesn't go deeper in the data, just need the high level data. So this would create the summarization of the data. So after creating the table and running this, we will be able to verify this data. While we were discussing, I just copied the three statements to here, right? Again, don't forget if you are running this to change that to FSI Gold, right? Because it should be uh, in the right spot. So I'll open here again just to show that there's nothing in this sleeve, right? See, no data. In this case, as I added all of them here, right? I can click on run all and they will run in the sequence, right? So first we are going to create a table and you see the table here. All right, so soon we should be able to see the table. Yes, see, we have the table. Now we are loading the data. And then after that, we are going to verify the data. I'm not going really deep on this because it's exactly what we've been doing all the time. So creating a table, loading the data, and verifying, but it's just interesting to show you that. Okay, so as you can see, where's the data? Oh, I think that I didn't remove this. Let me see. I think that we should remove this. Yep, I didn't toggle that to off. So let me rerun this part. And then we'll be able to run the next one again. All right, so let me see now if we have any data. We should have data. Yes, as expected, now we see 28,000 users. And here as a result, we have an example of the data here with per customer having their rewards tier, the total spending, total amount earned, total transactions, and things like this. Just before opening for the last part of the QA, for those that are running now and for those that are going to run later, The lab number 4 shows how to consume this data through Amazon Quick. For those that doesn't know yet, the Amazon Quick, it's one of the tools that AWS offer to work with agents and other Gen AI related tools. In this case, we have space, chat agents. If you remember also the quick site dashboards, we have the dashboards here inside as well. And everything from the analysis and dashboards, for instance, you will see that can be created by using natural language. So this lab here will help you to create a data set. So we are going to point to our S3 tables, as you can see here, and use the gold layer. See the gold, Customer 360, and add this data to Quick. After that, you will be able to create a chat where you will be able to talk to this data. So any natural language query that you can hit the chat itself, it will be responded. So questions like this: how many customers are in each rewards tier? The Amazon Quick will be able to go to the gold layer, because we pointed to the gold layer, and run queries there and bring that as a natural language response. Also here, there's a way for us to create a space, which means that we are going to create a kind of knowledge base in this case, right? And create our own chatbot to be used just for this subject. So we create a specialized agent, actually, in this case, and use that in the chatbot to ask questions like this. And just for you to see, this is the way that it looks like. Yep. So we have here, sorry, the testing the agent. Yes. See, from the data, we can create dashboards. We can create some other stuff, which you can, for instance, explore during the usage of this lab, right? So let me show you. So for instance, here we give you an example for it, but for instance, build a customer 360 executive dashboard with KPI summary that does this and that, a rewards tier distribution chart, blah, blah, blah. So all of this, as you can see, we add as a text and ask to preview the analysis created. It will take a few minutes, or 1 to 2, 5 to 10, sorry. And it will create a dashboard like this, for instance, for you. And we also show in this lab how using natural language, you could change the type of charts that you have here. You can add filters, so on and so forth. I tried to be as quick as possible, but cover everything. And then now I'd like to open the rest of the time that we have here for the last questions.
Yeah. All right. Thank you so much, Ricardo.
Sure.
So yeah, so definitely Lab 4 is going to be fun. I know that not
Yes.
everyone is able to kind of get their hands onto the lab or workshop today. So, and we are so sorry for that one. But again, as I said, we will share the link and a new link, maybe by end of day today. And but I'm not promising, because we are still working on fixing those issues. Hopefully by end of day today. If not, by Monday morning, we will be able to share that link with you. So once we share that, you will have about 72 hours to kind of work on it. So I promise Lab 4 is going to be more fun when you use Quick and then try to access your Iceberg tables. I would say, like, don't miss that one for sure. And yes, and then there are a lot of questions we try our best to answer. But if there is any question that you think that has not been answered, so now is the time for you to unmute yourself and then ask that question, right? So we have about 10 minutes before we wrap up this event today. Yeah, so please feel free to come unmute yourself and then ask your questions if you think your question is not answered, or if you have any new question, feel free to ask this. All right.
And thanks for the emojis. We You guys made my day. Thank you.
Yes. Yeah, we appreciate it. And then one final thing. Please, again, share, share your feedback here. I just pasted a link in the chat window, so please click on that link. Submit your feedback. It won't take more than 30 seconds. This is very important for us to improve our content, and then come back to you with a better content, better agenda. So please, we need your help here. Yes, and one final thing. So all these 2 days, these sessions have been recorded, so we will be editing them to kind of trim the size, and then we will be sharing it maybe next week. Again, it takes a little while for us to edit these recordings, so give us some time. We will try our best to share these recordings as soon as possible, but not today. It's going to be either on, maybe most likely it's going to be on Tuesday next week.
Using the moment, I want to say huge thanks from my side. I'm sitting second day at 9 of evening listening all of you.
I know you are the best. You are the best. Yes, that
And
helps a lot. Yeah.
one wish from my side, please distribute your sessions, because yesterday I had to miss your first session about Lakehouses because I was on your session about Redshift. All of them are very tasty, very interesting, and I like very much how you deliver it with practical samples, not only presentations decks, but presentation decks were yesterday fantastic. So continue. I'm super happy to see. I will continue sitting at 9 of evening listening to you.
Awesome. All right, this is really good. It means a lot to us, and thank you so much for your kind words. And as I
Do you
said,
have
like we will
other
be sharing those
workshops
recordings.
like this in, do you have other workshop like this in this topic upcoming?
So
Do you have any
specific
plan,
to,
any idea?
so you asking us specific to Iceberg?
Iceberg,
Uh,
Redshift, I like all of them. Very interesting and very actual.
Okay. So if you're interested in our events, there are a lot of virtual events going on. So what I would suggest is to kind of go to this link that I'm about to share.
if I know that in the different cities you have event like this, is it on the on those
Yeah.
cities? Do they have the same agenda or no? They may
It
have different
changes. It
agenda.
changes. The speakers change. The agenda is different. We have a bunch of in-person events. We also have virtual events. So I just shared a link to our
Do you know
connected
when is the
community.
next virtual event for this topic?
For this topic, I need to go back and then take a look. So we don't have anything
Okay.
planned immediately. But again, it depends on the ask. We might schedule one. So I think the best thing for you to do is like click on the link that I shared in the chat window and then search for Iceberg. If you're interested in Iceberg specific topics, search for Iceberg. If you're interested in Redshift, search for Redshift. I know that we are doing a bunch of Redshift specific events in the coming days. Ricardo is very much part of
Yeah.
those events, and I will be part of some of those events if not. So again, maybe Ricardo, you want to bring up the Redshift event? Are we doing any
Yes. So
are we doing any virtual event for Redshift?
not
Does
virtual.
the
The next
Redshift
one.
have the connectivity to Iceberg as well?
Yes, it
Yes.
does. Yes, it does.
Mm.
We do not have any virtual events at this time, but if you were in Chicago area, we are going to deliver this next Thursday, August 13. This will be focused on the how Redshift uses AI internally and also can uh, it can help AI. So, for instance, how Redshift is AI ready in this case. So we can use Redshift as a knowledge base for Bedrock, or through SQL, we can reach an LLM and bring more information, or transform our select statement answer, the output of the select statement, into a text to be sent to a customer or something like this. The Redshift AI driven scaling, how it works, which helps you right sizing Redshift depending on your workload, and so on and so forth. And we also have one part where we talk about the Iceberg reads and writes and the way that Redshift is dealing with that. But for now, we don't have any virtual event scheduled.
Thank you.
But things are so dynamic, we might come up with one. But again, it's very difficult for us to inform you all. But we try our best. But I think this is a place where you want to keep looking for any events or upcoming events.
Yeah, I'll post the Chicago event here. If anybody is in the area, please let me know if you were in this. I'll be glad on talking to you in person.
All right. So any more questions? We have 2 more minutes. And any final words, Jay?
I see here, is S3 tables a lake house? In this case, we consider, for instance, Redshift as a lake house, or because we can access both data internally to Redshift and also data outside, which can be in S3 tables, in Iceberg format, or even in standard S3 in Iceberg, Apache Parquet, JSON, whatever type of file that you have. But if you also consider that your data is formatted as a data warehouse in S3 tables, regardless the engine that you are using, you could call that lakehouse as well. S3 tables less expensive than a basic Aurora MySQL DB with one table. I would say depends on your usage in this case. They are different in some ways and depends on how frequently you access, because the S3 table, the Aurora itself, unless you are using Aurora serverless, you also pay for the storage and the utilization of the resources. With S3 tables, depending on what you are doing, it could be same, I don't know, cost for the storage, but depending on how you access, it depends. There's no right or wrong or way for me to tell, hey, Aurora is more expensive or S3 table is more expensive, depending on your way. Okay. Is there any way you can live stream the Chicago event? Yes, unfortunately, we don't have any streaming for the events, but we are constantly having streaming events. We did some few weeks ago, actually. Let me see here. I think that there's a list in somewhere, right? I remember having a list in somewhere. Hadi, do you remember what it is of the?
Yeah, which one are we referring to? Sorry.
Oh, here. So you can access the next events here. So for instance, this was, so you can see whatever we are going to have events, and you can filter by streaming or in person, as far as remember. Languages. Yeah, we have some here and some are online in something. See, when you see here online. So there are some online, but I don't remember having any other for Redshift or Iceberg online so soon.
Right.
Okay.
Cool. All right. So this is great. Thank you so much. And then thanks for being patient and then, staying with us for 2 days. Really appreciate it. And as promised, you will
How
see
about
those
the how
recordings
about the
soon.
AWS? How about the AWS context? That service.
Yeah, so AWS context is going to come in a few months. The announcement has come through. The service is actively working towards a preview and release. So if you remember in the view of my session, I was showing you a semantic layer. AWS context is going to kind of bring a kind of a graph, kind of a construct to be able to store all the relationships, right? When you talk about relationships, column name, metadata, relationships, and all of those in a graph-based structure. And that's kind of the crux of that service, but watch out for that announcement to come soon.
And if we already have 4 or 5 tables in our Iceberg S3 table bucket, all of those things, can I experiment this AWS context?
Not yet, but you can experiment with glue context, the one that I shared today. So glue context is available and you will be able to experiment with that.
But it doesn't have any graph representation.
No, not yet. There is
Okay.
another link I will drop in the chat. There is a open source version that AWS has released. It is called Context Ontology Accelerator, and I will share the GitHub link for that. And this is something you can use today. It basically creates a set of CDK stacks for you, and it'll basically create a Neptune and a graph behind the scene, and it'll give you a UI where you can go in and automatically ingest your glue tables that you're talking about, and then do a graph-based search. So this is something you can do today.
Very nice. If I'm assuming that you will have big announcement in November, December, big AWS in Las Vegas, huh?
Yeah, that's the idea. Okay.
All right.
Awesome again. Thank you so much again. I really appreciate it. We'll see you again. Hope so. Take care. Bye bye.
Thank you. Bye.